So yesterday we were talking about the nuclear energy and the biofuels. So let me talk about ocean thermal energy conversion system. So I was just telling you, so the tremendous amount of energy which is being available in the ocean. In the ocean also we will get why we call it as the ocean thermal energy sources means even in the ocean we can extract the energy, we can harness the energy which is available in the ocean in a four different form, in a three different forms. One is a wave energy, second one is the tidal energy, and the third one is the ocean thermal, the temperature difference. So in this context I would like to discuss only the one which we are using the thermal energy which is being available in the ocean. No, it is a process or a technology of producing energy by harnessing the temperature differences. The temperature differences are thermal gradient. What do you mean by thermal gradient? See, don't get panic. Whenever I say thermal, it is related to heat. That's it. Whenever I say thermal, it is related to the heat only. What do you mean by thermal gradient? Thermal gradient means for example, I would like to tell you, if you start boiling the water, at the bottommost portion of the water, which will be more hotter than the surface water at the beginning of the heating. Do you agree or not? So that means there is a temperature gradient or a thermal gradient. That means there is a difference in the temperature along the depth of the water. If you start heating a spoon, you take a spoon, and if you start heating the spoon like this, if you are heating it like from this end, the temperature at here will be more compared to the temperature at here. So there exists a temperature gradient along the length of the spoon. So this is what we call it as a thermal gradient, or we also call it as a temperature gradient. So likewise, since most of the people they think that the ocean is deeper, but you don't have an idea, ocean will be deeper in kilometers together. So the kilometers together, the deepest point of the ocean is around 15 kilometers it seems. The earth, the deepest point, the deepermost point of any ocean which is existing on earth, it is around 15 kilometers it seems. That means it is so deeper that even the light will not penetrate to the depth of the sea. Got my point? So the light will not penetrate up to the depth of the sea. You just imagine if you go to any swimming pool, the light will penetrate and you can see the bottom. You just imagine even in the afternoon 12 o'clock, the light will not be visible at the depth of the sea. So much of a depth the ocean will be there. In such cases, when please point to be noted, when the light is not penetrating to the depth of the sea or it is not penetrating to the deeper points, that means that it is not getting the heat. Point to be noted, isn't it? When it is not getting heated, obviously it will be cold. The water, the surface water which has been exposed to solar radiations will be hotter. So there exists a temperature gradient or a thermal gradient. This difference in the temperature will be utilized for converting this thermal energy into electrical energy. Sir, is the temperature difference is sufficient enough? Yes, it will be sufficient enough provided the working fluid should have a very low boiling point. I will come to that later on with a sketch. Ocean thermal energy conversion is a process that can produce electricity by using the temperature difference between deep, cold ocean water and warm tropical surface waters. This is what I was just talking about. The cold water, the deeper water which is not exposed to, which is not getting the heat or a light from the sun will be colder, whereas for the water which has been exposed to the surfaces will be hotter. Is it clear? So that is the idea behind of it. Next, the ocean thermal energy conversion system plants pump large quantities of deep cold seawater and surface seawater to run a power cycle and produce electricity. This temperature difference can be used to produce electricity and to desalinate the ocean water. So this temperature difference is being used in order to convert into the electricity. This OTEC uses the ocean's warm surface water with a temperature of around 25 degrees centigrade to vaporize a working fluid which has a low boiling point, such as ammonia. Ammonia is nothing but NH3. NH3 ammonia, if you can remember in the first year or in elements of basics of mechanical engineering, what you have studied in your early stages of engineering, where we used to talk about refrigeration system. There are two types of refrigeration system. One is vapor compression refrigeration system, which we call it as the VCR, and vapor absorption refrigeration system ಅಂತ ಎರಡಿತ್ತು ನಮ್ಮ ಹತ್ರ. One is VCR and the other one is VAR. In the vapor compression refrigeration system, we use a different refrigerants. In a vapor absorption refrigeration system, we used to have the working fluid as ammonia. Do you remember? This ammonia is used in vapor absorption refrigeration system because it has got a very low boiling temperature. What is the boiling temperature of a water? It is 100 degrees centigrade. What is the boiling point of ammonia? It is around 4 degrees centigrade. So obviously, even if you get it into the normal atmosphere, it will get evaporated. Its boiling point is very less. Is it clear? Which has a low boiling point such as ammonia. The vapor expands and spins a turbine coupled to a generator to produce electricity. Is that clear? Now I'll show you the diagram over here. Now you can see it here. You have a turbine over here. This is an evaporator. This is an ammonia pump. See, this is a condenser and this is sea water. Now you can see here the bottom of the cold water of the cold water which is at the depth of the sea will have a temperature of 5 degrees centigrade. This 5 degrees centigrade water will be pumped over here. Is it clear? Now this 5 degrees centigrade pump water will be pumped over here and it will come and this is ammonia pump. There will be a parallel things actually. Now you can see it here. Ammonia will be flowing through this channel and this is an evaporator which is also called it as a heat exchanger. This is also called as an heat exchanger. Now the cold water which is coming here will not flow over here, my dear friends. Please be careful. I will come to that later on. Initially the ammonia from this pump will be coming out to the evaporator. When this ammonia is coming through these pipes, will be subjected to a warm water at 25 degrees. At 25 degrees centigrade, now I told you ammonia has got a very low boiling point between 4 degrees centigrade to 10 degrees centigrade. So one which boils at 4 degrees or 10 degrees centigrade, what happens? It will be boiled. So soon the ammonia which comes over here, can you able to make it out here? In the evaporator, which what is an evaporator? Evaporator is the one which takes the heat and evaporates the working fluid. That's it. Evaporation, what do you mean by evaporation? Converting from liquid state to the vapor state. From the liquid state to the gaseous state ke convert ಮಾಡುತ್ತೆ. That is what we call it as an evaporator. Is that clear? Or it is also called as an heat exchanger. Now here what happens? The ammonia which is coming over here with a very low boiling point will be exposed. Will be exposed means it will be flowing through the pipes. Now this pipe, if it is surrounded by water, what happens? The pipe in which the ammonia is flowing, what happens? It will be converted into gaseous state or in a vapor state, and it just goes out. There is no physical mixing. The seawater and the ammonia will not physically mix. You just imagine this is a pipe. Inside this pipe, there is a, and if I keep this pipe in a hot water, what happens? The ammonia will get the heat and it will be converted into gaseous state. So the gaseous or a vapor ammonia will flow to the turbines and it makes the turbines to rotate because it has got, whenever, see my dear friends, I'll tell you basic physics. Whenever we are converted from liquid, from solid to the liquid, liquid will have a higher energy level than solid. If I convert liquid into vapor state, vapor will have a higher energy level than the liquid state. So we are converting ammonia, liquid ammonia into vapor ammonia means it is of higher energy level compared to the liquid ammonia. This higher energy level of the ammonia will makes the turbine blades to rotate, and this turbine will be coupled to a generator shaft. A generator shaft. When this turbine rotates, even the shaft also rotates, and this shaft will be coupled to a generator. It will be coupled to a generator which generates electricity. Okay, now after this ammonia which makes this turbine blades to rotate will come out of the turbine. It will go like this, it will make the turbine blades to rotate and it just comes out. It is an exit point. Now this vapor ammonia which has been come out here, will be subjected to, will undergo a condenser. Will undergo inside the condenser. It is something like, it is like an opposite to the evaporator. What happens? In the evaporator, liquid state will be converted into gaseous state. In condenser, gaseous state is been converted into liquid state. Now what happens here? Please be careful. It is once again, it will be flowing through a number of pipes. The gaseous ammonia, when it is of higher energy level, it will be hot. So if it is being subjected to a cold water at 5 degrees centigrade, what happens? It will be condensed. It will be condensed and it just comes back to the ammonia pump. Is that clear? Now this is what the, once again ammonia will go here and it just comes back here. So this is a circulate. This is a closed cycle wherein which completely it will be extracted like this. My dear friends, this you may feel difficult, but I will give you a line diagrams in the notes that will be easy for you to analyze. Now here I would like to come back over here. Condenser and evaporator, they are exactly opposite in working function. Condenser, I'll give you one better example. When a pressure cooker is giving a visual, if you keep a spoon, what happens? It strikes the blades and condenses into water. If you take a spectacles, if you do it like this, what happens? The hot gases, when it touches the cold surface, it will be converted into a liquid state. The same thing will happen. The coldness will be taken out by this and convert this into liquid, and the heat which is being present in the vapor ammonia will be given out. So this purple color will indicate hotness, whereas here it shows the coldness. Is it clear? Condenser is also called as a heat exchanger, wherein which the cold water converts the liquid ammonia into, I'm sorry, gaseous ammonia into liquid ammonia. Now you can ask me, sir, what is the problem if it is gaseous only? You can ask me, sir, what is the problem if it comes with a gaseous? As you said, the vapor state will always have a higher energy level. Then what is your problem? Why can't why can't you use the same thing? No, my dear friends, I can pump the liquid ammonia, but I cannot pump the gaseous ammonia. Is it clear? So I cannot pump the gaseous ammonia back to the turbine over here. Higher energy level, though it has got a higher energy level here, it loses a part of the energy. Higher energy level means it will have an enthalpy. Enthalpy means heat. A part of heat will be converted into mechanical energy here. I was just telling you, energy can neither be created nor be destroyed, but it can be converted from one form to the other form. So the heat energy which has been possessed by the ammonia is being converted into mechanical energy. So the rest of the little amount of energy will become out here. I want to give it more energy to convert the turbine. That is first thing. Second thing is, I want to pump this ammonia in a gaseous state. That is second thing. Third thing is, if I allow the same gas to go to the turbine, it will not rotate it because it has already lost its partial energy. Is it clear? That is the reason why we will go there. Now here, the warm water or a hot water, I would say 25 or 30 degrees centigrade, if it is coming over here, it loses its heat to the liquid ammonia, converts that into a uh, gaseous ammonia. This is how it just circulates. This is the idea behind of ocean thermal energy conversion system. It is really a wonderful to achieve these things, but somewhere we lack of conversion rates, because the major thing is, it is because the sea water or ocean water will be very saline in nature. When it is more saline in nature, obviously the scaling factors will come into picture. What do you mean by this scaling factor? Scaling factor means, you might have seen it in your normal homes, where the pipes will be collected with the salt thing. it will be collected with the salt thing. It will reduces the inside diameter of the pipe. So the same thing will also happens here. And this ocean will have lot of dissolved salts in that. So that is one thing which reduces the performance or efficiency of converting this OTEC into the electrical energy. Is it clear? This is the idea behind of it. Maybe you need not to deliver the same 3D sketches in your examination. I will give you line diagram that will helps you to draw a picture. Is it clear? See this arrow marks and all those things you have to represent it in a proper way so that okay. Next one is a tidal energy. Tidal energy is also obtained from the oceans. I have always told you there is always a difference between a wave and a tide. A wave is something above the level and it just comes down. Thrust and craft. That is what happens. Like your wavy form. Electronics people might be knowing it. It's a wave is nothing but something like this, and tide is something which produces a kinetic energy and it comes and hits the shore. That is what we call it as tidal energy. Tidal energy is a form of hydropower which converts the energy obtained from tides into other useful energies. Okay. The tidal energy is the result of sun and moon's influence over the ocean. Tidal energy is also called as tidal power. My dear friends, how you there is one interesting thing. You might have seen the tides and the waves will be more stronger during full moon time, and it will be less as the full moon progresses into crescent moon. Crescent moon is the crescent moon or a half moon as it progresses. Have you heard about this? The ocean will be having more tides during the full moon time. Why it is so happens? Why the tides are more stronger in a full moon time? It is only because the gravitational force of attraction between earth and moon is same, is more. That is first thing. Second thing is the angle of rotation, the direction of rotation of both moon as well as the earth, it takes place in the same directions. That is the reason why the tides are more influenced. And maybe you might have heard about it. Earth has got more 70 to 77% of earth is covered by water. Then definitely when you have a gravitational force like this, obviously it will influence the tides. I will go in depth. There is a one particular model in the fifth wherein which we have to deal in depth for this tidal energy sources. Tidal power utilizes the energy contained in tides to produce electricity. Tidal energy is a renewable energy powered by general rise. Okay, now tidal energy is a renewable energy source during a high tide when the level of water in the sea is high. Seawater flows into the reservoir of the barrage and turns the turbines. The turbines then turn the generator shaft. I will explain this with a better one. Now here what happens is, you just imagine these are the sluice gates. What do you mean by sluice gates? Civil people will be knowing it better. It is something like a dam. You might have seen it. Dams will always have a gates. Is it clear? When it move downwards, it will block the flow of water. You just imagine, my dear friends, you just imagine if these sluice gates are closed like this, the high water level which has been present at the right side will have the more water that will be stored over here. This is what we call it as a tidal basin. The tidal basin wherein which the water is being stored with a higher height which possess the potential energy. This potential energy, when I open this gates, this is a turbine tunnel. This is a tunnel means a small passage wherein which the turbines is been fixed. When the water is flowing with a higher velocity over here, makes this turbine blades to rotate, and it goes to the other part of the ocean. How long this turbine will rotate? As long as the potential energy is more for this and makes the water to flow here. Once there is a steady state is been reached, then what happens? The water will start flowing. Once it reaches both the height of the water becomes same, so the water will stop flowing to the. Is it clear? So once the height of the water reaches over here, then we will allow the water to flow over here. It is simple logic. Even if Jatragala Hodaga, you can see the hand fans. There used to be fans and you used to hold it like this. If you go against to a wind or a air, what happens? It rotates. The same logic will holds good over here also. The potential energy of the water will be converted into kinetic energy of the water, and then the kinetic energy of the water will be converted into mechanical energy. Then the mechanical energy will be converted into the electrical energy. This is the idea behind of the tidal energy. Actually, even in the tidal energy there are three different types are there: single tide, double tide, all those things are there. That we will go deeper when we talk about this OTC in depth in the fifth module. Okay, what is a wave energy? Wave energy, also known as ocean wave energy, is another type of ocean-based renewable energy source that uses the power of the waves to generate electricity. Unlike tidal energy, which uses the ebb and flow of the tides, ebb means the passage wherein which the difference in the water level. That is what we call it as an ebb. Okay, and flow of the tides. Wave energy uses the vertical movement of the surface water that produces tidal waves. Wave energy is a transport and capture of energy by ocean surfaces waves. Now, have you people enjoyed in beaches, wherein which if you go deeper, the waves will come up to your height, and then it will make you to sink down, and then it will go once again. And even you might have experienced, if you are standing near the tides, it will take you away to the shore and comes back, it will drag once again back to this. So that energy over here, the wave energy or a wave power is a transport and capture of energy by ocean surface waves. The energy captured is then used for all different kinds of useful work, including electricity generation, water desalination, and pumping of water. So for these purposes, the wave energy is being used. It's a green energy and friendly to the environment. Producing power from the waves creates no gas, waste, pollution, or any harmful byproducts. That is true. So only it is called as a green energy. Now here you can see it here, my dear friends. Now I could have shown you better pictures, but I wanted to explain the physics behind of it. You might have heard about the piston and cylinder. Even you might have used the plungers for your bicycles for inflating the football, basketball. How does it work? There will be a plunger and there will be a cylinder. It just goes inside and come out. It just goes inside and come out. When it is going inside, you have to apply more pressure. When you are releasing, it is takes like air from the outside. So the same thing over here, my dear friends. When this is a piston and this is a cylinder, the piston will start moving upwards when there is a rise in the wave. When there is a fall in wave, obviously the piston comes down. The same piston and cylinder arrangement you might have studied. So this, what happens when the wave is raised? The piston moves upwards and the gas inside this or the air which is there inside this will be compressed to a very high pressure and temperature. That is first thing. And second thing is, since there will be continuous fall and up and downs will be there. So what happens? The piston will start completely moving up and down, up and down, up and down. What is this movement we call it as? What is this movement is called as reciprocating action. This reciprocating motion is being converted into electrical energy. Is that clear? Have you ever seen this reciprocating compressors? You have seen it. The reciprocating action, even in your college, you have a reciprocating pump in the fluid mechanics lab, wherein which by this reciprocating action, it will pump the water. The same way, this reciprocating mechanical energy will be converted into electrical energy. This is the idea behind of this wave energy. Then this is a geothermal energy. Geo means earth, thermal means heat. This heat which is got entrapped inside the earth is being used to generate electrical energy. Now, my dear friends, I will tell you a small story. Actually, this how this earth is been formed. When this galaxy is been formed, obviously what happens? Earth, you might have heard, this complete earth has been formed because of the Big Bang theory. Once this earth has been formed, it was a hot molten solid. It was a very hot molten solid which completely with melted lava volcano it was there. So what happens after millions of years together? What happened? This started cooling down. As it started cooling down, the surface has come to this stage millions and millions of years ago. What happens if you go deeper into the earth? As you go deeper and deeper into the earth, what is happening? It at the core of the earth part, at the core of the earth part, it is still hotter. That is the reason why you can see, you can hear about volcanic eruptions. What do you mean by volcanic eruptions? When this volcano comes out, or the lava which comes out, it will be a molten metals. It will be melting point. If you put your fingers, or even your bone will not also comes out. So such a huge temperature it will be there. So those heat, it is being used to convert that heat into electrical energy. Very interesting this is actually. And this heat we cannot extract it everywhere. There will be a few spots wherein which you have to extract the heat from the particular places. Now this geothermal energy is a renewable energy sources because heat is continuously produced inside the earth. Geothermal energy is the thermal energy generated and stored in the earth. Earth's internal heat is thermal energy generated from the radioactive decay and continual heat loss from the Earth's surface. The temperatures at the core mantle, I was just talking at the core mantle, it is of 7,200 degree Fahrenheit or around 4,000 degree centigrade. 4,000 degree centigrade is a very huge. If you put water, suddenly it will be converted into steam. Geothermal energy is a heat that is contained in the ground and is considered a renewable energy source, such as wind energy. Exactly. Now here you can see this production well. This is a geothermal zone. Now please be careful here. There are different types are there. At the earth crust, we will have a rocks, a big rocks. A rocks maybe of a size of this half of this Haveri. Such a big rocks will be there. That will be too hot. That will be too hot. That hot rocks maybe of 200, 300 degree, 400, 500 degree centigrade. It will may be having it, and then it will. We also can have a hot gases. Hot gases can also be there, and the third thing is we will have a molten lava which might be flowing. All these zones we call it as geothermal zone. At this geothermal zone, you can see it here. This is a production well, Bhavitara. It is a production well from which the heat is been taken out here. The heat has been taken over here, and this heat is being used to convert the water into the steam. The steam will start flowing over here, high temperature steam. It makes the turbine blades to rotate and convert this mechanical energy into electrical energy. Once the energy has been given out to the turbine, what happens? The steam temperature reduces and this low temperature steam is being sent to this water. Now this water is being sent to the cooling tower because I always told you we want to cool it and we should also filter it. Okay, we have to filter it and we have to cool it and we will send it back once again over here. Now here, what happens? The water when it comes and touches the surface of the hot source, suddenly it will be converted into steam and it will go over here. Now you can ask me, sir, if that is the case, inside there will be a lot of dust and dirt particles will be there. Doesn't it get mixes up with that? Certainly, yes. Even you might have seen it when we bore, when we drill the earth to get the water. initially we will get the rocks and we will all get all those things. In order to separate that, we will extract the brine solution or the waste brine. We are not getting only the steam, we will also get some salts, some rocks, some dust particles, some sand particles, everything will be there. So we will separate this steam and we will separate the brine solution and we will send it out. So this is the idea behind of geothermal energy sources. Do you got it? Okay. Now this tar sands and oil shells, I just talk to you tomorrow. Okay.